All right, so we just barely finished about talking about some binary trees, and you were given the little homework assignment of creating a binary tree with this information. Okay, so if you look at this value, the very first value is going to be the root of the tree. So 67 is going to be in this position right here. And then 10 is going to go to the left of 67. And go ahead and pause the video, check your answers, make sure you got this right, and we will go on. Okay, so the next thing we're going to show you is just kind of a demonstration of the order of binary trees. So suppose I'm creating this binary tree, and that means 2 is the very first item into the tree, and it gets placed at the root of the tree. Then we're going to add a 4 in, and 4 is larger than 2, so it's going to go to the right. Then we're going to add a 5 in, and it's going to go to the right. Well, since all of these values are in order, it's just going to create one long branch of this particular tree. And so as far as efficiency goes, remember we talked about the height of the tree determines the efficiency. This is not very efficient. If we're looking for the value 21, we're starting at the beginning of the list and going all the way through the list. We're traversing the list. So as far as efficiency goes, the order of the tree does matter, because the order you add items to the tree determines your tree shape, and the shape of the tree determines how efficient it is. But the advantage is adding is easy, searching is super easy. There's less traversing than a linked list in normal situations, and still you have small pieces that are stored throughout memory instead of one big chunk of data like the array is. Okay, the next one we're going to talk about is called a queue. A queue is kind of like waiting in line at Disneyland. Items get ordered, the first item that gets there is the first out of the list. So anything you put in the list is added to the end. Anything that you remove from the list is added to the front. So suppose we have a tunnel and a maroon car goes in, and then a red car goes in, and then a blue car goes in. Well, what car is going to come out of the tunnel on the other side first, assuming there's only one lane? Well, that would be the one that went in first, the maroon car, and then the red car, and then the blue car. So let's show you kind of how this works. So you have your information and your list, and you have something pointing to the front of your list, which is called the head. You also have something pointing to the end of your list called the tail. And so anything that you add to the list, when you're ready to add to a list, you call an in-queue. In-queue just puts items onto the queue, and D-queue removes items from the queue. So suppose we're doing a queue at Disneyland and adding names to the particular queue of information, like what is they call the fast pass or something like that. So if we call in queue Athena, that's going to put her in the line. Then both the front and the back of the line are pointing to her, since there's only one item in our list. Now we're going to in queue Brittany. So that means where Brittany goes to the end of the line, and we push the end of our line, our tail, back to point to Brittany. Now we do Carrie. And Carrie gets added to the end of the line, and once again we change our tail pointer to point to the end of the line, which is now Carrie. Well, now it's time to take someone onto whatever ride, maybe it's the Matterhorn, I don't know, at Disneyland that you happen to be queuing for. Who's going to get to go on the ride? Well, it's the person at the front of the line. So if I call DQ, that will take Athena off, and it will move our head to Brittany. Brittany is now at the front of the line. Okay, so let's have you practice this. I'm going to stop the video here, and you're going to figure out what the queue would look like after performing the following operations. Write it on your worksheet first, and then I'll tell you the solution in the next video.